wizard. You're a hero, and you look great.
Hello everyone, welcome to this new video. So it's been a quite long time since I uploaded any video. So I've come with an exciting concepts today, wizard concepts of mathematics. So we were doing sequences and series. So I'll just continue that. There will be two more videos of sequences series. Today I've come with two important things of sequences series. One is AGP, like sum of n terms of AGP. I know mostly no one will teach it because people feel like sum of n terms of AGP is a weird equation, is a big equation. We don't need to remember. We can do it as usual process of shifting the terms by right and then subtracting them and then getting it into Tn and everything. Like people have all these methods, but the thing is even doing it in this way actually works out. It's not like you'll be getting a different answer. You'll be getting the same answer as what you do it in the non-conventional way. This is the this is a conventional way, like we using a formula and doing it is a conventional way. So you can use it, you can use both the methods, but I would actually prefer using this. And also we'll be discussing the method of differences. So I'll explain you what is it actually. Many people don't know it, what is method of differences. Actually they lack solving this type of problem, like complex problems of sequences series due to lack of these concepts and all. Yeah, so let us start this. So sum of n terms of AGP. Okay, sum of n terms of AGP, and then we'll be taking a special case of infinity terms also. So you know, right, like you people know what is n term of AGP. Like how can the AGP series would be like the series can will be in this way: a plus d into r plus a plus 2d into r square plus so on a plus n minus 1 into d into r power n minus 1, right? This is the Tn. A plus d, a plus 2d plus so on a plus n minus 1 into d. So this is the AP, and GP starts from here: r square so on r power n minus 1. So Sn, this is Sn, right? This is Sn because sum of n terms is, this is what your Sn is. Now you can just multiply by Rsn, like you can just multiply by r on both sides. You get AR plus a plus r, a plus d into r square plus a plus 2d into r cube plus so on a plus n minus 1 into d into r power n. Okay, this is what you want to get. Now you can just subtract these two. Okay, you can just subtract these two. 1 minus r Sn is equal to a plus, what you do is you just need to shift the terms by one side. Like if I need to be so clear about that, yeah, so if I need to be so clear about that, like I can just write Sn equals to a plus d into r plus a plus 2d into r square so on, right? And when you multiply by Rsn, you just shift one terms here. Okay, just shift the terms by right. You get AR plus a plus d into r square plus so on. Okay, now you just subtract these. When you subtract, you get Sn into 1 minus r equals to a plus r into d plus r into d r into r, like r square into d plus r cube into d plus so on. At the finally you will be getting dr power n minus 1. So this will be your one series, like you can just keep it at one side, plus the last term that you will be remain with. Like when you shift all the terms to the right by one term, you will be getting an extra term here. which there is no term, like there is no term in the like in the above thing from which you can subtract this. So you'll be reminded with this, that is minus of a plus n minus 1 into d into r power n. You don't need to think that much because this is rsn, so the last term would be a plus n minus 1 into d into r power n, and that is what will be left with. So this is what you're gonna get. And this is nothing but like if you see this series, if you see this is a GP, like this is a GP, geometric progression. You can just take the d common and you can just check it out, it's a geometric progression. So for that you will get a general expression in this way: a plus dr into 1 minus r power n minus 1 divided by 1 minus r. Alright, so dr is the first term into 1 minus r power n minus 1 because n minus 1 terms are there, divided by 1 minus r, and minus a plus n minus 1 into d into r power n. Alright, this is what you want to get. So if I just like if I just move like be more in like put the simplified version, you get Sn is equal to a by 1 minus r plus dr into 1 minus r power n minus 1 divided by 1 minus r whole square plus sorry, it's minus a plus n minus 1 into d into r power n divided by 1 minus r. Alright, so this is what you want. Like some people may argue like this is a joint equation, why do we use it? The thing is, we have derived this from the non-conventional method only. Alright, we have derived this from this non-conventional method of multiplying by r and then shifting the terms to the right by one term and then subtracting them, and you are getting a general form of Sn. So either of the way is acceptable, but for like I feel like using this is somewhat easier than doing all this stuff. Like there is a chance that you might do some calculation error and all, so that's the reason. Now for infinite terms, alright, now for infinite terms, like your AGP is like a plus d into r, yeah, a plus d into r, a plus 2d into r square, and this goes on. Okay, there is no limit. So people say that there are two cases in this: r greater than 1 and r less than 1. There is no case for r greater than 1. Okay, there is no case for r greater than 1. If r is greater than 1, your series would be just expanding, right? If your series would be just expanding, there is no way to limit your sum. You cannot calculate the sum where it diverges, like it goes on diverging, like in this way it goes on diverging, it doesn't converge. Alright, so you cannot calculate when infinite terms, and there is no question that can be formed also. If like if r greater than 1 and infinite terms are there, find the Sn of this series. You cannot find even, it's infinity. Okay, so only case will be possible as r less than 1. So in these cases, how to do it? So if I will just like I'll just break this formula. It's a by 1 minus r plus dr by 1 minus r whole square minus dr n divided by 1 minus r whole square minus of a plus n minus 1 into d into r power n divided by 1 minus r. This is what, right? SNS. As I've told you, r will always be less than 1. Okay, r will always be less than 1, nor it doesn't work out. Alright, r should be less than 1. In precise, I would say mod of r should be less than 1. Then only you can calculate this. Mod of r should be less than 1. It's not like r can be minus 4 or minus 5. No, then also it diverges in the negative way, but its mod of r less than 1 means whatever value you take, negative or positive, its mod should be less than 1. Then only you can define an infinite series, like its sum, and you can come to converge that to a certain value. So because mod of r is less than 1 and n is infinity, alright, n is infinity here, this both like this will approximately equal to be 0.0000 something, so it's almost 0. And the same case here also, r power n, so r power n in the sense 0.000 something, because 0 point, like if I take mod r to be 0.5 and power infinity, in the sense it's going up, like it's almost converging to 0. So so it's 0 into this, it's completely 0. So whatever the things you are left out with is this a by 1 minus r plus dr by 1 minus r whole square. So this is what you want to get. So this is s infinity. Alright, so this is an s infinity. If infinite terms are given to you and you are asked to calculate the sn, like s sum of the terms of the series, you can just put this formula. A is the first term, 1 minus r is the geometric progression ratio plus common ratio plus d common difference into r divided by 1 minus r whole square. So these are the two important formulas. You can just have a look at them. And coming to the other concept, that is method of differences. So basically why do we use this method is like if I give you some series like a b c d e something, like it's not a series, it's a sequence. If I give you a sequence, the difference here is b minus a, the difference here is c minus b, the difference here is d minus c, the difference here is e minus d, right? So these are the differences. But what if I ask you, like for a b c d e, if there are in a b, you must say like b minus a should be equal to c minus b, isn't it? If I tell you that a b c d e are so on are in till z, okay, a b c d so on till z are in ap, so you would say that the difference between the first and second will be equal to the difference between second and third, and you can just find the tn to be a plus n minus 1 into d is b minus a. So you can just find the tn for this expression, right? But what if I say that it's not an ap although, but you can even find the tn of it, okay? It's not an ap, it's not an gb, it's not a hp, it's not a agb, but still we can find a tn for this. We can find the sequence, like the tn for the sequence. But how is it possible, and what are the conditions for it? So if the differences, and now that if I take the differences, these are the differences, like if these differences are in ap, okay, these differences are in ap, not the terms are in ap, the differences like b minus a, c minus b, d minus c, if these are in ap, then we can find the tn of this sequence. All right, not only that case, also you can even find the differences between these two terms and these two terms and these two terms, and if they are in ap, not being them, like a b c d is what we have taken, the differences is b minus a, c minus b, d minus c, e minus d, and so on. And if I tell that these are also not in AP, but the differences of these differences, like yes, b minus c minus b of c minus b minus of b minus a, d minus c minus of c minus b, e minus d minus of d minus c, those terms will if they are in AP, then also we can find the tn for this sequence. All right, so how do we do it is the question. So I'll just take an example for this and explain you like the question is, it's a general question, you might find this in many works. I'm taking an easier ones. So the sum of the series 1 plus 5 plus 12 plus 22 plus 35 plus 1. All right, so if you just check from here, it's not an AP, you can clearly see that, but the difference is like 4, 7, 10, 13, these are in AP, right? The difference is 3, 3, 3. You can see that these are in AP. So how to do this type of problems is, the SN is nothing but 1 plus 5 plus 12 plus 22 plus so on, right? This is the SN. So I'll be doing this like this is Tn minus 1 plus Tn. Alright, Tn minus 1. Wait, I'll just move it. Tn minus 1 plus Tn minus 1 plus Tn. Now what I'll be doing is I'll just like shift these terms by one right side, okay? So I get Sn one, like I'll just shift this by one side, like one term to the right. I get 1 plus 5 plus 7 plus so on. Here I would be getting Tn minus 2, here I would be getting Tn minus 1, Tn minus 2 plus Tn minus 1. Just a moment, guys. Yeah, Tn minus 1, and lastly, like Tn minus 1 below Tn, and lastly you'll be remind with plus Tn. Okay, there's nothing in the upper thing that can subtract this, so I'll just subtract these terms right now. If I just subtract this, I get 0 here, I get 1 here, I get 4 here, I get 7 here, I get 13 here, no 15, 22 minus 7, right? Like 12 minus 5, it's 7. 22 minus like I have like I just skipped one thing, 4 and 22. So the next term is 22, and I just subtracted these terms. So 12 minus 5, 10, and yeah, sorry, it's 12 actually. 1 plus 5 plus 12, so it's plus 12, right? So 22 minus 12, it's 10. All right, so this goes on, and this finally you will be reminded with Tn minus 1 and minus Tn, right? This is what you're gonna get, and you just shift this Tn over here, you just shift this Tn over this side, you get Tn to be 1 plus 4 plus 7 plus Tn plus so on, Tn minus 1, isn't it? This is what you're gonna get, Tn minus 1. So this is basically nothing but 1 plus 4 plus 7 plus 10 plus so on till n terms, because Tn minus 1 and here plus Tn minus 1, those will be getting cancelled. You'll just get those cancelled, and actually you'll be reminded with n terms here. So this is basically nothing but, so if you see these are in AP, 1 plus 3 4, 4 plus 3 7, 7 plus 3 10. So you can get a general expression of this like n by 2 of 2 into a, that is 2, plus n minus 1 into 3, right? This is what you're gonna get. So it's n by 2 of 2 plus 3n minus 3. So it is n by 2 of 3n minus 1. Alright, so n by 2 of 3n minus 1 is what you wanna get. And this is the general expression of Tn. So this is the general expression of Tn. So if I would give you with Tn, how do you calculate the Sn? Sn is basically nothing but sigma Tn, right? Sn is nothing but sigma Tn. So it's sigma 3 by 2 n square minus half n. So it's 3 by 2 of sigma n square minus half of sigma n. So it's 3 by 2 of n into n plus 1 divided by 2 into 2n plus 1, and here it is 6, and minus of n into n plus 1 divided by 2. Alright, so this is what you want to get. So this is a general expression for this Sn. So sigma n square n into n plus 1 into 2n plus 1 divided by 6, and minus of half of n into n plus 1 divided by 2. So the main concept is how do you apply this? Like you just need to shift these terms by one side, like one term, and then subtract them, and then you can just bring this Tn to this side, and this is nothing but n terms up to n terms. So it's AP, because the differences are in AP. That's the reason we have got this into an AP, because with the subtraction is what we have done. So subtraction in the sense we are actually subtracting the terms and we are getting the differences. So this is what you want to get. So this is how you actually solve this using a method of differences concept. I'll take in another problem. This time with like this problem is like 1 plus 4 plus 10 plus 20 plus 35 plus so on. Alright, so this is the question given to us. So if you just see this, the difference is 3, the difference is 7, the difference is 10, the difference is 15, and so on. These are not in AP. 3 plus 4 is 7, 7 plus 3 is 10, and 10 plus 5 is 15. So these are not in AP. 3, 7, 10 are not in AP. Yeah, actually this is 6. 6, 3, 6, 10, 15 are not in AP. But once again, like these are the differences 1. I would mention this to be differences 1. Like the first time that we have taken it differences, so I would mention it as D1. Now if I take the differences again, I get 3 here, I get 4 here, I get 5 here. and now these differences are in AP, isn't it? Now these differences are in AP. So as I've told, method of differences works out in the cases when the differences are in AP. Alright, in the differences are in AP or GP, like differences should be having some sequence, rather the terms are being having some sequence, the differences should be having carrying some sequence with them. So these D2 are in AP. So how do you do it? It's the same thing. Sn is 1 plus 4 plus 10 plus 20 plus so on, Tn minus 1 plus Tn. So here now again Sn is, just shift these terms by right, 1 plus 4 plus 10 plus so on, Tn minus 2 plus Tn minus 1 plus Tn. So you can just subtract them. You get 0, 1 plus 3 plus 6 plus 10 plus so on, Tn minus Tn minus 1 minus Tn. Alright, now you can just shift this Tn over here. You get Tn to be 1 plus 3 plus 6 plus 10 plus so on n terms. And now this Tn I will be writing as Tn is equal to 1 plus 3 plus 6 plus 10 plus so on. Small t I will be mentioning this nth term of this. So Tn minus 1 plus Tn. Now again I'll shift this terms by one term towards right. I get 1 plus 3 plus 6 plus so on, Tn minus 2 plus Tn minus 1 plus Tn. Now you can just subtract them again. You get 0 equals to 1 plus 2 plus 3 plus 4 plus so on, Tn minus Tn minus 1 minus Tn. So you can just shift this Tn here. You get Tn is equal to 1 plus 2 plus 3 plus 4 plus so on till n. So it's basically n by 2 of 2 plus n minus 1 into 1. So it's n by 2 of 2, it's n by 2 of n plus 1, like it's just a sigma n, right? Sigma n, this is Tn. So for Tn, like this is that small Tn, for capital Tn you just need to put sigma for it. So sigma of n by 2 of n plus 1, you will get Tn. And for Sn, sigma of Tn, the value you will be getting from this, you just need to put sigma for it, you will get the Sn value. I hope you guys got this. So this is how you do it. The differences, like the set of differences that actually matters. The first set is in difference, you'll be just subtracting them and you'll be getting the capital Tn. If the second set of differences are in AP, and then you'll be doing it once again, you'll be repeating the step, like how many times the differences are in AP, that many times you will be, like which set, it depends upon the set. If it's D1, you'll be stopping at capital Tn. If it's D2, you'll be stopping at small tn. If it's D3, you can just put on going something, like you can have the other variable and solve it. So I hope you guys understood this. A very good concept. So coming to the next thing is method of references shortcuts. Like I can even give a problem to this. Like till now we have discussed in the AP form. What if it's in GP? I'll take a problem of GP and I'll solve it. So the terms are 1 plus 5 plus 18 plus 38 plus 179. It could be 58, I think. Yeah, it could be 58. 1 plus 5 plus 18 plus 58 plus 179 plus so on. Alright, so this is like find the nth, like yeah, like for this we'll be finding the Sn. So how can we do it is, if you see it, the like you can just look at it in the AP form and then say it, but it doesn't work out. I would say like it's in GP. Basically the common difference here is 4, the common difference here is 13, the common difference here is 40, the common difference here is 121, and so on. And once you again, if you like, this is the D1. Okay, so D2 is 9, here it is 27, here it is 81, so it goes on. So if you see the D2, it's a GP, right? It's a GP with R is equal to 3, with R is equal to 3, because the common ratio is 3. So the second set of differences are following a pattern, and that is a GP. Alright, that is a GP. So how do you do it? The same thing. Sn is equal to 1 plus 5 plus 18 plus so on, Tn minus 1 plus Tn, sorry, I would mention it to be capital itself. So Tn minus 1 plus Tn. So same thing, just shift that by one side, 1 plus 5 plus so on, plus tn minus 2 plus tn minus 1 plus tn. Alright, so just subtract these terms, you get 0 here, you get 1 plus 4 plus 13 plus so on, plus tn minus 1 minus tn. So shift this here, tn, you get tn is equal to 1 plus 4 plus 13 plus so on, tn minus 1. So this is basically you can just put it to n terms. Okay, you can just write it as n terms. So this is at tn is equal to 1 plus 4 plus 13 plus so on. This n terms is tn minus 1 plus tn, and again tn minus 1 plus tn, just shift this by one term. So you get 1 plus 4 plus 13 plus so on, tn minus 2 plus tn minus 1 plus tn. Alright, tn minus 1 plus tn. Now you just subtract these terms. You get 0 is equal to 1 plus 3 plus 9 plus the other thing is 13 is right. So after 13, like you can just see it, you'll be getting till n terms here. Alright, this is till n, like you can just put it in this way, tn minus 1 minus tn. So tn is 1 plus 3 plus 9 plus so on till n terms. So this is a GP with common ratio equals to 3. So you can just solve it for this. A into r power n minus 1. This is 3 power n minus 1 minus 1 divided by 3 minus 1, right? This is the sum of it. So like actually it's yeah, 3 power n minus 1 divided by 3 minus 1, because there are n terms. So a into r power n minus 1 divided by r minus 1. So it's 3 power n minus 1 divided by 2. This is tn. So how do you get capital Tn? You just need to put sigma for it, right? Sigma of 3 power n minus 1 divided by 2. So it's basically you can just bring the half outside. So half of sigma 3n minus half of n, half of sigma 1, right? So it's half of sigma 3n 3 power n minus half of sigma 1. So it's half of, it's 3 power, like starting from n is equal to 1, I think. Yeah, starting from n is equal to 1, you just need to put it, right? 3 power 1 plus 3 square plus 3 cube plus so on, 3 power n and minus n by 2, because sigma 1 is n by 2, sigma 1 is n, so it's n by 2. So this is again a GP. So for this GP, 3 into r power n minus 1 divided by 3 minus 1 into half minus n by 2. So it is a 3 by 4 into 3 power n minus 1 minus n by 2, right? So this is Tn. This is the Tn that you're gonna get, and you can just put sigma for this. Okay, just put sigma Tn, you get the value of Sn. So this is how you do it. So the concept is very simple. You just need to shift the terms by one side, shift the term by one side, like one term, and then subtract them. Like that depends upon the set. If it's d1 is in the following some pattern, so then you need to stop at capital Tn itself. If d2 is following a pattern, not d1 and the terms, then you can stop at a small tn. So this is how you do it. So mostly most probably they'll be stopping at this moment itself, at the d2 itself. So you don't need to do that much of you don't need to proceed further. So this is how I'll conclude the video, because it already crossed 30 minutes. It's almost approximately equal to 30 minutes. So I'll just stop this video here. In the next video, Wizard Concepts of Mathematics, there is another method, Vn method. So I'll be discussing that, and also that important part of means. Actually many people don't discuss it. I'll be discussing that. So these two concepts I'll be covering in the next video. So thank you for watching. I hope you all understood this, like sum of n terms of GP and then method of differences. Very important concepts, wizard concepts. These actually boost your marks in any exam, or even like you can just be happy learning these type of concepts, because these are we are not so reluctant to those. We have no many people don't teach it. So I hope you guys understood all these concepts. So thank you for watching this video. Stay tuned.